Just gotta show you the new doors and the windows up there. I cut some acrylic to put there, double layers. So much light. Really nice actually. Also got a 3D printer, so made this adapter for this thing to fit on there. It's so wonderfully easy to do, and this stuff is super durable, so nice. Anyway, I wanted to talk about vacuum because it's weirdly enough quite fascinating. As previously mentioned, this is HDF. It's a high density fiberboard, contrary to the medium density fiberboard. You can clearly tell this is a lot more rough than even this is. This is also MDF, but this is an MDF plus. Different manufacturers call them different things, but it's just higher density and it's meant to be better for cutting. And if you read online, all you're gonna see is people basically recommending LDF or just something super porous. And that's not necessarily the best thing. It's actually worse, depending on what type of pump you have, of course, and what type of vacuum table too. If you have a high flow, like those side channel blowers, then of course they can't produce that much pressure. Well, it's decent, but it's not amazing. Maybe they can get down to like 600-700 millibars. Whereas the rotary vane pumps that I have behind this wall, they can reach, what was it, 3 millibars. There's one model that can go down to half a millibar. Not that that's gonna, be relevant at that level, because I'm not gonna have 3 millibars at the table itself, but it's good. But it's not as much flow though. I have about 250 cubic meters per minute. Or is it by the hour? By the hour, of course. 250 cubic meters by the hour. And that's nothing compared to a side channel blower. But then again, you don't want that much leakage. And I've used higher and higher densities and gotten better results each time. Of course, it's harder for the pump to pull through it, but it does. And as long as it does, that means the condition above this and underneath the aluminum in this case, that's going to experience that super high, low pressure. So it means it's going to be on there. But if this was slightly porous or it was slightly bent like this, and there's a gap somewhere, it's super hard to get it to actually, well, not 2 millimeters, but if it's thicker. So, because the flow isn't that much, but once it's there, it's stuck to it. I've even got a pen here. Let's say this is absolute zero, when outer space when it comes to vacuum, and this is like 1K, well, millibar atmosphere. This is at 1 atmosphere, 100 kilopascal. And let's see here, my pump would be like, that would be the performance curve of one of these rotor vanes. And let's say somewhere around there is 100 millibar. So that means the pump doesn't even slow down until it reaches about 100 millibars. That's when it starts to, pump less and less air because, it's harder to pump. But it can go to like 3 millibars. So let's say that's there. Like a vacuum cleaner, a regular one, the manufacturers specify, let's say 260 kPa or millibar. Is that 26 kPa then? Yeah, anyway. So let's say 260 millibar, but they're talking about from here, you can remove 260 millibar from current pressure. And that's, you know, differs if you're up on Mount Everest or if you're, depending on where you are, but I don't care about those things. I care about this thing. So a good vacuum cleaner comes to, like, let's say there, and a high performance like 5 kilowatt side channel blower might be there or something. And there's also dry running claw rotary pumps. Those typically reach around 150 to 250 millibars, which is, I mean, that's good. That's probably more realistic for what you're going to experience at the table anyway, because you're always going to have some leakage. My plan is to get this stuff, which is HDF. Oh, my brain just stopped working there for a second. And cover this entire table. And I'm not really that keen on even keeping these vaults. I want to use this space for something else. Sure, I was thinking of using pneumatic ones anyway, but I'm not that much of a hurry, because I've tested this before. You might have seen that video where I had like a quarter of the table open and was still a really good vacuum hole down there. So if I just remove all of these, because these freaking hoses, you're not supposed to use hose anyway, they restrict flow as it is. So this one and this one come together in a T there, goes through there, into that T, and then all the way back through the wall. So it's super inefficient. So my thinking is that I'm just gonna keep everything open and cover it with this HDF, because the flow is so low anyway, and I have a secondary pump should I need it. And if I'm only running smaller standard sheets, then I cover this with a pre-cut plastic piece or something. I mean, that's easy enough, but I really think it's gonna give great hold down. And of course, it's not the cheapest alternative to keep swapping out these humongous sheets, but they're not that expensive. And I can, because I haven't been using most of the table since I've only had a spoil board like this big. So I could start cutting sheets here until it's too messed up, and then start over here and then start over there. And I could probably even flip it. I'm not sure that would give that much better result than just running it the way it is, but a little bit for sure. Then again, I have used this stuff before, which is basically the same thing as HDF. It's that super thin layer on top. I'm just gonna... Come on. It's somewhat of a hassle when it does these wrinkles and stuff. Focus, you fack. But you can get it there in case you want to cut something special just there and you don't want to use wear on your spoil board. You could use this and just not go through this stuff. I mean, the hold down is super good. Kind of hard to show, but it's really good. And that you could do just to save on that big sheet if you really wanted to. I have used this stuff more before, in case you're wondering why I don't use it over the entire table, because it's so cheap. The reason is to have it stay there when I'm loading and unloading is a pain. And it's meant to crinkle to use as package material, so that when I've used it, I crinkle it and put it in a bag, but it takes a lot of space. So, I'm gonna use these HDF sheets instead. And also, there's hardboard. Hardboard is manufactured in different ways. There's a wet process, there's a dry process. And the dry process is supposedly quite identical to HDF. So I'm gonna try and order some of that. Then the wet process is supposedly not even air permeable at all, just like Masonite. Masonite is a brand and their process makes it non-air permeable. And then there's oil treated Masonite, which also is a no-go. It's just super tight. Yeah. So that's what was in my head this morning. What else? So I just recorded a bunch and I hadn't hit the record button. So here goes again. Anyway, a problem is, of course, that HDF isn't produced super high precision thickness wise. I read somewhere it was up to 0.15 millimeters, which is kind of nice anyway, but it's not good enough for high precision engraving or nothing. And since I don't want to surface it because the hold down gets much worse even though things get flatter. UC-CNC has a plugin, well, some guy made a plugin to probe the entire surface that you want to engrave on beforehand. I want to buy a probe and put it there. That would solve all of those problems. And of course it's too bad that I still haven't gotten UC-CNC, because I was meaning to buy one of their controllers and give it a test drive. I have used their controllers and software before and I like them. It's just that they don't have even S-curve motion profiles, and the motion from this controller is just fabulous, but they don't have a user forum, and it's kind of hard to tell what's on the roadmap and when new features or plugins or whatever is coming. I don't know if they're gonna implement, you know, a probing routine for the table thing anytime soon. And I have to chamfer both sides on basically everything I produce for the Swedish Army. And of course I can easily chamfer the top side, and there's a million different ways to flip it and know where it's at, so I can chamfer both sides, but I don't want to go around flipping everything. So the most important thing is just breaking the edge too. That's also for the powder coating, because the powder itself, it kind of avoids these sharp edges, so it's so much thinner and, well, weaker at those sharp edges. So it's all about breaking those edges, and my plan is to use, well, test if I can use this after I've cut with a 4mm end mill, then use this to come in and just slightly break the edge of that bottom profile. Since I'm probably cutting 1/10 of a millimeter into the spoil board anyway, then there's room for this guy. We'll see how that goes. Would be wonderful, but in order for that to work, it needs to be super flat, like surfaced or probed, to make that happen. We'll see, I guess. I really also like an Xbox 360 controller for this. It looks super sweet on UC-CNC. What else? These angular contact bearings in here. These are like 20 years old, and if I tension the screw too much, it gets super notchy. So those probably need to be replaced, but it's over $500 just there. And this isn't running actually super smooth. I don't know if it's the pinion that's manufactured to a different spec or something than the actual rack. I mean, it works, and it's there's no play in it or nothing, but at certain RPMs or speeds, I mean, there's quite a bit of vibration all the way out here. I don't know, so at some point I might replace these anyway for helical ones, but I was actually just planning on using this for as long as possible because it's, you know, it's working. So I'll probably do that. I would like a probe, as I said, on there, and a high speed, like 60,000 RPM spindle next to it, so I can do faster engraving and also chamfering, because I chamfered at 18 meters a minute, which is just crazy. And sure, I could use a better chamfer tool for it, but then you can see these like tiny notches. So the RPM of 32,000 isn't quite enough for that speed. But I mean, it's fine. I bought this from Sorotech in Germany for measuring all my tools, because right now I'm just resetting them on the table every time and it's super tedious. It's, I mean, it's kind of nice. It was quite expensive. I can't remember what it was, but it was quite expensive. What I'm a bit worried about is this is steel and it's not super light. And these end mills I'm using from Crown Norway, they're so super hard. I mean, the hardest thing I've ever seen, that they become brittle at the very tip. So I can't probe at any speed at all if I don't want to break them, and even slowly this would be scary. So I might put a piece of, I don't know, tape or something there to cushion it just a little. I don't know, it just might be my stupid brain playing tricks. Anyways, that's about it. Talk to you next time. Bye.